Okay. One more thing about this diagram. C. This C. So what's happening at C? C, we have a local maximum. And what else do we notice? We notice that there is a horizontal tangent line, right? There's also a horizontal tangent line over here and over here. Okay, this gives us a great little method for finding maxima. Okay, so that's where we're going now. So horizontal tangent line means f prime is 0. Okay, so f prime is 0, a very special place on our graph. So definition. A critical number is a real number C in the domain of f such that either f prime of C is 0. That's the most kind of obvious one. There's another one that's not so obvious, or f prime of C just does not exist. So critical number. So let's do an example to illuminate here. So one of two places, it's when f prime is 0 or f prime does not exist. So 80% of the time, okay, most critical numbers, I want to say, okay, in a standard Cal 1 scenario, are going to fall under this category. Okay, but you got to watch out for this one too. So we call these critical numbers. And why do we care? Because critical numbers, that's where my tangent line is horizontal, usually. Or I think you agree it's a very important feature of a graph. So if we're trying to sketch these graphs, these critical numbers are important to us. Example. Find the critical numbers, CNs, so short form, the critical number of f of x is equal to something naughty, 3 over 5, do 4 minus x, right? Okay, so what am I going to do? Well, I'm going to find out when is f prime 0, and also find out when does f prime not exist. F prime equals 0. Well, what is f prime? F prime of x is equal to product rule. 3/5 x minus 2/5, I believe, yeah. 4 minus x plus f g prime. And then minus 1. Right? And then solve by factoring. Factor the smaller power of x. Okay, x to the minus 2/5. And then, oh yeah, it's good enough. I could get fancier, but I'll just factor the smaller power of x and leave the fanciness for another day. Oops, no, minus x. All right. Yeah. Okay, then what do you get? X to the minus 2/5. And inside the bracket, I get 12 over 5. Lovely. And then minus 3/5 minus 8/5x, I think. Okay. And then I simplify as much as I can. So I should say factor. And we have 5x to the 2 over 5. Okay, well, I go again. 4 can come out. 3 minus 2x all over 5x to the 2 over 5. Oh yeah, let's double check that I didn't butcher that. Oh, looks good. Okay, this is 0. Then how can that fraction be 0? Well, the numerator has to be 0. So x is 3 over 2 is a critical number. Okay, but it's not the only one, right? Because we have to check, f prime does not exist. Where does that occur? It occurs when x is equal to 0. I'm looking at, oh shit, did I just touch the mic? I hope not. Okay, looking at this expression. Okay, I noticed that I cannot plug in x equals 0 because that would cause division by 0. Okay, so that's where this is coming from. Now I should check that x equals 0 is in the domain of f. Okay, I have a gander at f itself up here. And can I plug x equals 0 in there? And the answer is yes, I can. I'll just get 0, no problem. So x equals 0 is a critical number as well.